Hello friends, welcome to CBSE e-learning. In today's class, we will be doing physics model question papers. I'll be solving the complete questions of this model paper. Please do watch, like, subscribe and share to your friends. Thank you. So we'll get on to the question paper. Here first three questions are chemistry and biology, I guess. So we'll be going on to question number 4, which is a physics question. Why do sun appear white at noon? So answer for fourth question. So we know many phenomena of nature, for example, reddish red color sky during sunrise and sunset, blue color of sky. So these all phenomenons and even white color sun at noon. So for all this phenomenon, the main principle is atmospheric scattering of atmospheric scattering of sunlight. Since during at noon the distance from the sun to the earth is less, the sunlight travels the least distance during at noon. So the component colors of sunlight will refract in such a way that after refraction they recombine to emit as a white light itself. So the main reason is least scattering. Least scattering, as least scattering is a reason that at noons sun will be, the distance between sun and earth will be less, so the least scattering of sunlight is the answer. You need not write the entire thing, only just a ask for 1 mark. So answer is the least scattering of sunlight. Hope you have understood. We are moving on to question number 5. So question number 5 reads, a both spherical mirror both a spherical mirror and a thin spherical lens have a focal length of minus 15. So focal length is negative and it is minus 15 centimeter. What type of mirror and lens it is? So we know two types of mirrors, that is concave and convex. Concave and convex. And we have two types of lenses, same. One is convex, another one is concave. And we have studied sign convention. All the measurement towards your left is negative, all the measurement towards your right is positive. Negative, positive, negative, positive, negative, positive. Since image is formed on for a convex lens on positive side, so we are eliminating convex lens. Same way, for a convex mirror, the image is formed on the positive side. We know it is a virtual image for a convex lens, so you have studied it. So this also image is formed on negative side, so we are eliminating this. The option should be then it is a concave mirror and concave lens. So answer for this is concave mirror and convex. Mirror is which type of mirror they are using? They are using a concave mirror. And what type of lens they are using? They are using a concave lens. Hope you have understood. So we are moving on to question number 6. The image formed by a concave mirror is observed to be real, inverted, larger than the object where is the object placed? So question number 6 reads, the image formed by a concave mirror. Concave mirror. So concave mirror means, I'm keeping here concave mirror. So concave mirror, and it has pole, focus, center of curvature, and it is infinity. So when I keep at infinity, the object is formed at focus and it is point sized. When I keep somewhere between center of curvature and infinity, the image is formed somewhere between center of curvature and focus, so it is lesser than the height of the object. So when I keep at center of curvature, so the image is formed at center of curvature, same size of object. Then if I keep an object between center of curvature and focus, my image will be somewhere beyond the center of curvature, and it is inverted, enlarged, that is enlarged, and it is a real image. We know real image are the image formed in front of mirrors. So in front of mirrors. So where is the object kept now? Object is kept between C and F. What is C? Center of curvature. What is F? Focus point. Hope you have understood question number 6. So question number 7. Question number 7. So we have question number 6 as option question also, and you can even try for the option question also. Name the part of the lens through which the ray of light passes without surfing any deviation. So we know that in the lenses we have a part, or we have a part of lens called as optic center. Optic center, and whenever a ray is incident on optic center, it gets refracted with the same path. That means there is no refraction at all. The light travels in the same path as that of incidence. Same way we have in mirrors. Mirrors also gusset. So gusset, what is a part of the mirror in which the ray of light after reflection passes in the same path? Guess it, and we will get back to you. If you don't get any answer, just text in the comment section, so I'll reply it. So question number 7 is a physics question again. The arrangement shown in the figure, there are two coils wound on a non-conducting cylindrical rod. Initially, the key is not inserted in the circuit. Later, the key is inserted and then removed shortly after. What are the observations that you can note from the galvanometer? So this is an experiment of Faraday to show that moving charges, magnetism generates electric current. What happens here again? So we know that there's a battery and the current starts flowing here. When the current starts flowing here, when suddenly the key is on, there is a sudden change in electric field. Change in electric field. This change in electric field induces magnetism, the sudden magnetism, that is 0 to max it goes. Then this change in magnetism, since this coil C1 is connected to coil C2 with the means of electric rod, this magnetism, this entire rod makes magnet. So there is magnet produced. Magnetism, property of magnetism can be experienced in coil 2. This change in magnetism induces current in the galvanometer. This induced galvanometer, the current in the coil 2 makes the galvanometer pointer to deflect for a shorter interval of time, only till some time, that is change in magnet, until the magnet goes to a steady state. So magnet starts from minimum, goes to some steady value, so or saturated value. Till then there will be deflection. Once the saturated level is reached, that means steady state is reached, this galvanometer comes to its original position. So what you observed, now we observed that, so there will be a deflection in the galvanometer for short time. Why is this reflection be there? Because of induced electric current. And you know that the direction of induced current can be found using Fleming's right hand rule. Go back and study what is right hand rule again. Draw a mass again. Next question. Draw the magnetic field lines around a straight current carrying conductor. We have seen in magnetism, magnetism, this third chapter of physics, that whenever in a straight conductor, if current is flowing from upwards, and the magnetic field produced will be concentric circles between this conductor, and if I place a plane perpendicular to the conductor, on this plane I can sprinkle some iron filings so that this iron filings will align along the direction of magnetic field. And the rule we use is right hand thumb rule to find the direction. What right hand thumb rule says? If your thumb points the direction of current, then fingers encircling gives the direction of current. So when a thumb is upwards, my fingers will align in this direction. So what is this direction called? Anti-clockwise direction. So if current is flowing from down to up, what type of magnetic field produced? Anti-clockwise magnetic field is generated. This can be even drawn in another way also. So current can be going from top to bottom. In the same way, the magnetic field produced concentric circles to the plane perpendicular to the current carrying conductor. So then if you apply your right hand thumb rule, thumb points downwards, this is the thumb, and my fingers encircling will be in a clockwise direction. Clockwise direction. Hope you have understood this. So draw the magnetic field line on the straight conductor. So answer is this. Any one you can draw, not necessary to any one of it. Any one of it you have to draw it. We go to the next question. That is question number 9 is a physics. Two unequal resistance are connected parallel. So two unequal resistance are connected parallel in a parallel circuit. Remember that always between any resistors the potential difference will be same, but currents divides into I1 and I2. Current is divided. If you are not provided with any other parameter, numerical value of I and R, what can be said about the voltage drop across the two resistors? So answer is very clear. They have not been given I value, R value, nothing, but I can say that the voltage drop between these two unequal resistors will be same. So what will be the answer for the question number 9? PD across both resistors are same. Why PD across the both resistors are same? Always PD is measured between 2 points, since the two resistors in a parallel connection, not only to any number of resistors, they are always connected to only 2 points A and B. So if you measure the potential drop across any of 2 points, it will always be same. Hope you have understood. We're seeing some R question with 9. Some work is done to move a charge Q from infinity to a point A in a space. The potential of the point A is given as V. What is the work done to move this charge from infinity to it? So we know that this is just a formula of potential difference. Question number 9 R question is potential difference is work done to move a charge. So what is the relation? V is equal to W by Q. Hope you have understood the answer of our question with 9. We are going on to next question. So others are biology, I guess. So forgive me, I'm not a biology teacher. I'm only a physics teacher. I'll be doing it. And in the next video, I'll be solving even chemistry also. We will later on see it. As of now, I'll be clearing your physics questions in the first video. assertion and reasoning. So since the first one is a chemistry, second one is a biology, and third one is also a biology question, so no need to worry about it. And we are going on to case study based questions. Case study based questions, first one is a biology, and second one also, I guess. And here we don't have any kind of physics questions. Here is chemistry question. Yeah, we got the read the following and answer any four questions of 1901 to 1905. Sumati wants to see the star of the night sky. She knows that she needs a telescope to see those in distant stars. She finds out the telescope, which are made up of lenses, are called as a refracting telescopes, and one of which are made up of one of which are made up of mirrors called as reflecting telescope. So there are two types of telescope they are giving. One is refracting telescope, another one is reflecting telescope. So that she decides to make a refracting telescope. So if she is deciding to make a refracting telescope, so she has to use what? Lenses, but not mirrors. She bought two lenses, L1 and L2, out of which L1 was bigger, L2 was smaller. If L1 was bigger and L1, yeah, sorry, L1 was bigger. If L1 was bigger means, so it has they are using the larger radius of curvature. If larger radius of curvature, so radius of curvature will be more L1, and radius of curvature is more. We know F is equal to R by 2. Even F also will be more. So compared to L2. The larger lens gathers and bends the light while the smaller lens magnifies the image. So what is for smaller lens is used for? It is used for magnifying the image. Big and thick lenses are more powerful. So to see far away, she need a big powerful lens. So what type of lens she has to use then? She has to use a big and powerful lens. Unfortunately, she realized that big lenses is very heavy. Heavy lenses are hard to make and difficult to hold at the right places. Also, since the light is passing through the lens, the surface of the lens has to be extremely smooth, because since the light is coming from a distant source, very distant source, we may even term to be as a point source also. Any flaws in the lens will change the image. It would be like looking through a dirty window. So this case studies, we got to know there is a girl called Sumita and she wanted to prepare a telescope. What type of telescope? Refracting telescope. She bought two lenses, L1 and L2, out of which L1 was bigger and L2 was smaller. And she also gives some information that powerful lenses, heavy lenses gives a good magnifying image, but to hold it will be difficult. And moreover, the big lenses should be extremely smooth, because the light from the star we capture will be from a far distance. So based on this, we'll answer this question. Based on the diagram shown, what kind of lenses would Sumati need to make the telescope again? So here we can see in the diagram that, so both the lenses, you can just see it, lenses, they are thicker at the center and thinner at the edges. So obviously it should be a convex lens. So what type of lens she is using then? She is using a convex lens. If the power of the lens is L1 and L2 are in a ratio 4:1, what could be the ratio of focal lengths of L1 and L2? We know that, question number 2, focal power of lens is nothing but 1 by focal length, and unit is diopter. Remember this when F is used as meter. If power is equal to 100 by F, if F is used in centimeter, and the unit is diopter itself. Remember, this is 1 mark question again. Since power is inversely proportional, so if I take P1 by P2, I get F1 by, sorry, it should be small letter, F1 by F2, sorry, F2 by F1. So we know that P1 by P2 is 4:1. Then obviously they are saying that L1 L2 reciprocal it, so we get F1 by F2 is equal to 1:4. So what is the ratio then? 1:4. Option B. What's the formula for magnifying object with lens? So we know magnification. Question number 12. Magnification for mirrors. Mirrors, it is minus V by U, or it can also be H dash by H, where H dash is image height to object height. Same way for lenses, it is M is equal to V by U, or it is H dash by H. You know what is H dash. And V, here V is image distance and U is object distance. So I'm giving some additional information also, so that gets glanced and revised for you. So the ratio of height of image to ratio of height of object is the magnification of lens. So for both lens, negative factor is again used because of the sign convention here. So next is, Sumati did the preliminary experiment with the lenses and found out that the magnification of eyepiece L2 is 3. So they have given that question number 3, magnification is 3. If the experiment that L2 was found to be image at 24, so image distance they have given, V they have given, that is 24 centimeters they have given, image distance. Remember, they have given that image distance. At what distance did she put the object? So she did some experiment, not that star experiment, she did some experiment. Image was found at 24 centimeters. So we know that magnification is V by U. They're asking us to find U. U is equal to 3, that is 24 by 3 turns out to be 8 centimeters. So where is the object kept at 8 centimeter to give an image at 24 centimeters. Hope you have understood this question. We'll be moving on to question number 5. I hope so. To answer the first 4 questions is very easy. Since the 5th question is a little bit tricky, you have to study the case study detailedly so that to answer the 5th question. Sumati bought not so thick lenses for the telescope and polished them. What disadvantages, if any, would she have with a choice of lens again? So we know that thicker, not so thick lens would not make the telescope very heavy and also allows a considerable amount of light to pass through it. So we know that what disadvantages, if any, would she have with her choice of the lenses. She will not have any disadvantages if thicker. No, we know that thicker lens we have some lenses. So not so, answer is not so thick lenses would not make the telescope very heavy. It's been given in the case study itself and allows a considerable amount of light to pass through it. Hope you have understood all the 5 questions of this case study. We'll be moving on to question number 20. Read the following and answer any 4 questions from 20I to 24 to 25. A solenoid is a long helical coil. We know that. Question number 20, solenoid. Question number 20, a solenoid is a long connected to a battery power source, positive, negative. There's a direction of current, direction of the current coming out. The magnetic field around the solenoid is superposition of the field due to the current through each coil. It is nearly, so that obviously we know that we have studied this solenoid. A solenoid is a long cylindrical copper wire, insulated copper wire wound in a helical shape, and here the magnetic field will be same as that of bar magnet. Remember, inside the solenoid the lines will be uniform and it will be same as that of bar magnet. So it is nearly uniform inside the solenoid and close to zero outside, and it is similar to the field of a bar magnet, having a north pole at one end and south pole at another end, depending upon the direction of the current. So obviously this north pole and south pole depends upon the current, and you have to use the concept of right hand thumb rule for a current carrying through a spherical loop. The magnetic field produces in the solenoid depends upon the few factors such as current and number of turns and unit length per unit length, that is small n number of, if the more number of coils are used, more the magnetic field. If the more current is there, more the magnetic field is induced in the solenoid again. So directly proportional both are. The following graph is obtained by a research while doing an experiment to see the varieties of magnetic field with respect to current in a solenoid. The unit of magnetic field is given in a graph in millitesla and the current is given in the amperes. So we got somewhere here 3 and For point 0.4 it's somewhere near 6.5, and for 6 it is somewhere near 9.5. 8 it is somewhere near 13. This is 13 and this is 16. So this is 13 and this is 16. This is 9.5 and this is 6.5 and this is 3. So these are the points we are getting corresponding. I'm telling x value is 0.2 only. I'm just marking this 3 and as a y values again. So what type of energy conversion? So in solenoid always the energy conversion is from electrical to mechanical. Why electrical to mechanical? If I keep a magnetic field, there is some force generated. Wherever force is generated, that force is called mechanical force. Why mechanical force? Again, we have used the concept of motor again. In a current carrying conductor, you keep a magnet, a force is generated. What is generated? Force is generated. A force always come to be as mechanical. So the conversion is electrical to mechanical, option C. What happens if a soft iron core is placed inside a solenoid? So whenever a solenoid is there, the solenoid behaves like a magnet unless the current is being passing through the solenoid. So if I keep iron rod, so this is a question second answer. So if I keep iron rod, a soft iron core rod, this iron core rod will be acting like a magnet until this current is being passing in the coil again. So until the current is passing, this soft iron core will be acting as a magnet itself. So answer for this is the bar magnet will magnetize as long as there is a current in the circuit, option B. Question number 3. The magnetic field lines produced inside the solenoid are similar to that of, since the case study only they have given, and remember the magnetic field inside the solenoid is same as that of bar magnet, and they are parallel lines, and the magnetic field at one end will be same as that of another end. Our magnetic field inside the solenoid is uniform because magnetic field lines are parallel to each other. After analyzing the graph, a student writes for the following statement: the magnetic field produced by the solenoid is inversely proportional to current. No, it is wrong because it is directly proportional. If the magnetic field produced in the solenoid is directly proportional to current, yes, this is correct. The magnetic field produced by the solenoid is directly proportional to square of current. No, it is directly proportional, that's all, not the square. The magnetic field produced by the solenoid is independent. No, this statement is wrong. So answer is question number 4. The answer is 2. The magnetic field produced by the solenoid is directly proportional to the current. So the magnetic field produced, so choose the following from the, so answer is only 2 statement is correct. From the graph, deduce which of the following statement is correct. For a current of 0.8 ampere, the magnetic field is 13 Tesla. So we'll see the first one. So first one, yes. So it is 13 millitesla for a current of 0.8. For a larger current, the magnetic field increases only. No. So it is increasing linearly itself. So this is wrong. This is correct. For a current of 8 ampere magnetic field, no, it is 13, not 1.3. Be careful. Here is 1.3. There is no enough information. No, there is enough information to find it. So answer is A itself. So for a current of 8 ampere, 0.8 ampere, the magnetic field is 13 millitesla. Hope you understood this question. We're moving on to the other question. So yeah, question number 25. Student observed that given phenomena in the lab as white light passes through the prism among many other colors, observe that the position of two colors, red and violet. What is the phenomena called? What is the reason for the violet light to bend more than the red light? So what is the phenomenon is called? The phenomenon is called as dispersion, because white light is splitting into component colors. Two component colors. So white light is made up of many colors. And again, violet. So reason for bending of light is wavelength. And we know wavelength, and it is lambda, and wavelength is inversely proportional to refractive index. So more the wavelength resembles that less is the refractive index. If less is the wavelength, more is the refractive index. So here for red color, usually it is more wavelength. So it is VGYOR. So this refractive index, the wavelength increases in this order. Violet will have less and red will have most. So red has more wavelength, which equals to refractive index to be less. So it will bend less. Least refraction leads to, so least refractive index leads to least refraction. So red bends less, whereas violet as lambda equal to more, and refractive index will be, sorry, lambda is less, refractive index will be more, so it will bend more. Got the reason why violet bends more than the refractive index? Because the refractive index of violet is more than that of red. Why refractive index is more? Because the wavelength of violet is less than the wavelength of red. So wavelength is inversely proportional to refractive index. Hope you have understood question number 25. We are moving on to question number 26. A student has two resistors, 2 ohm and 3 ohm. She has put one of them in the place of R2 as shown in the circuit. The current that she needs in the entire circuit is exactly 9. So she needs a current of 9 amperes and she is supplying 12 volts, and R1 is being clearly given, but R2 she has to take either 2 ohm or 3 ohm. Show by calculations which of the two resistors should choose. So first I will choose R2 to be 2 ohm. If R22 is 2 ohm, then I have to find that the overall current, to find that the entire circuit current, since here in a parallel connection current divides into I1 and I2, so I will be equivalent to I1 plus I2. So I have to find out first the effective resistance to find its current. So we know R effective, since it is parallel connection, the formula for two resistors is R1 R2 divided by R1 plus R2. So I am taking first R1 is 4 into 2 by 4 plus 2, so 8 by 6 I get, so 8 by 6 I get, it is 3 by 4. So the resistance is 3 by 4 effective resistance. So 3 by 4 means, so I have to find out the current now. Current is V by R from Ohm's law. V is 12 volts and R is 4 by 3. So you get 2 into 3 by 4. So 4 ones are, 4 threes are. So the current is 9 amperes. So in the first case 1 itself, I am getting current as 9 amperes. You need not to find for the other one. So obviously, what type of R2 first they have to use to have a 9 ampere? They have to use 2 ohms in place of R2. So if you use 2 ohms, the current will be exactly equal to 9. Hope you have understood this. Since this question is for 2 marks, so we will go ahead. So obviously, see, sometimes if you are lucky means you may get R2 directly the answer again by using R2S4. Or else if in case they would have given 3 ohm here, then obviously you would have not got. Practice, do it, see the same procedure and just check it. 3 ohm they won't get it. So if you don't get 3 ohm, then obviously it is understood that you have to do with the second one again. So next question will be question number 33. Question number 33 is a physics question. So refractive index of water with respect to air. So they have given absolute refractive index of, so refractive index we know NWO is 133, and they have given diamond also. N diamond is 2.44 absolute refractive index. So for any, and they are asking us, in which medium does the light move faster, water or diamond? Obviously, speed of light speed of light is inversely proportional to refractive index. That means more the refractive index, less is the speed. So here, less is the refractive index, more is the speed. So which has a refractive index less? Water. So obviously speed of light, the first question answer will be speed of light will be faster in water compared to that of diamond. What is the refractive index of diamond with respect to water? So they're asking with diamond with respect to water. So diamond with respect to water. Obviously, refractive index are inversely proportional. Absolute refractive index with respect to air they are asking. So it will be diamond means first you have to write water, that is NWO by C. Why is C? Because they have given it is absolute refractive index. This is N by C actually. Absolute refractive index is you are comparing the refractive index of any medium with respect to air or vacuum divided by Nd by C. Both get cancelled. So we get 1.33 divided by 2.42. So 2.42. So you have to do it. So it is 133 divided by 242. So solve it. You get this. Oh, sorry. They are asking us to find absolute refractive index. So absolute refractive index is C by NW. Sorry. It is reverse. Absolute refractive index is C by ND. So then you get sorry. Then you get this as C by NW by C by ND. So this is absolute refractive index or absolute refractive index of water, and this is absolute refractive index of diamond. And it is velocity of light in inversely proportional. So then this division will be 2.42 divided by 1.33. When you do it, 242 by 133. So you get 242, 133, 1 za 133. So you get 312, 901. So if I take point, I get I'll go for 8, 4 to carry, 26 to carry, 10. So somewhere nearby 8, 1064. So this is 8, 10, 6, 2, 0, point again 0. Okay, so approximately equal to 1.82. You get 82 or 81, both are correct. So approximately equal to, so that is ND by N water is 1.82 approximate. I've done approximation. So hope you have understood the question number 33. So we are moving on to question number 36. I guess this is the last question. So this is the last question. So the given circuit A, B, C and D are 4 lamps connected with a battery 60 volts. So all are connected in parallel. Analyze the circuit. Answer the following questions. What kind of combinations are the lamps arranged? So first answer is, so I'll write from here 36. The first answer is they are already connected in parallel. So it is one below the other. Explain the reference to your above answer. What are the advantages of this combinations of lamps again? What will be the advantages of a, so here all lamps are operated at same voltage, same potential difference. These are advantages. And if any one lamp is affected, other function of affected, that means there is any faulty functioning of other lamps is not affected. So that means all other lamps will function as it is if one lamp is any faulty or default. You can write these two advantages. Explain the proper calculation which lamp shows brighter? So always brighter is nothing but brighter of light. If they ask the brightest or brighter anything, you have to calculate power. And we know power is formula is V into I. Since V is same with the, you have to check I. So you have to show it in calculation. So we will show it, and I is more for lamp C. So we are doing it, power is equal to V. V is 60 into 5. So you get 60 into 5 is 300 watt. So power is 300 watt for 5 watt, 5 ampere lamp. So obviously, which lamp will be brighter? Then lamp C will be brighter. So you got the question number 3 answered also. Find out the total resistance of the circuit again. So you have to find the total resistance of the circuit. First find the total current of all the circuits. So question number 4 is easy method is total current. Total current will be equal to 3 plus 5 plus 4 plus 3. Okay, sorry, it is 4 plus 5. 4 plus 5. So it is, so 9, 12, and it is 15 ampere current is the total current is flowing in the circuit. So they are saying that we know that total voltage is 60 volts. So R will be equals to V by I from Ohm's law. Ohm's law. V is 60, R is 15. So 1 za and it is 4 za. So what is the total resistance? Total resistance is 4 ohm. So what is the total resistance of the circuit? It's actually called as RP, and the total resistance is 4 ohm. Hope you have understood all the questions. And there is our question also here. PQ is carrying conductor in a plane of a paper as shown in the figure below. Find the direction of the magnetic field produced by it at a region R and S. So we know that when current is upwards, right hand thumb rule, if thumb shows pointing towards the direction, then fingers encircling gives the direction of current. So what type of direction will be there? It will be concentric circles. And concentric circles are, again, this directions it is wrapped. So first one will be clockwise magnetic field. Given that R1 is greater than R2, R1 is greater than R2, where will be the strength of a magnetic field region? So we know that, so magnetic field strength, magnetic field is inversely proportional to radius or distance away from the conductor, current carrying conductor. Which is more now? R1 is more greater. And which is near now? S is nearer. So obviously magnetic field at S will be more. Magnetic strength at S will be more than at P. Hope you understood. Question number 3. If polarities of the battery connected to a wire is reversed, how would the direction of magnetic field? Obviously, direction of magnetic field also changes. So answer will be, direction of the magnetic changes. So answer will be anti-clockwise. So remember, we have already seen this in the first question. If you want, you can just rewind it and watch this current carrying in a straight conductor. I've shown in the beginning of this video with both directions again. Explain the rule that is used to find the direction of magnetic field for a straight current carrying conductor. Already we have studied this, and it is right hand thumb rule. So thumb points, they have said explain. So thumb points the direction of current, then fingers wrapping the conductor shows the direction of direction of magnetic field. So hope you understood. Thumb points the direction of current, then the fingers wrapping the conductor shows the direction of magnetic field in a current carrying conductor. So hope you have understood the physics part of the paper 1. So we'll be seeing the next paper in the next video. Thank you. Please watch, share, and do subscribe. If you have any queries and doubts, comment in the below section.